our first and most user-facing product that we have is the Voyager Block Explorer, which started in the very early days of StarkNet and followed through all of the gateway API changes and has been like keeping up with the features consistently, and was designed to try and be as minimal as possible for users so that it was pretty clear where everything was. It has been improving tons over the last few months, and we are actually just getting faster and faster. So keep an eye on Voyager's development. We've got a lot of cool features coming through the pipeline. It's a block explorer. It's the usual thing. I'm not going to get into it. Everyone here probably knows what that is. Some of the cool features that we have here are you can automatically identify what kind of contract it is, which is a cool thing that we do based off like contract class hashes, which can tell you if it's like a Bravos or an Argent or a proxy and other types. This is somewhat similar to tagging on Etherscan, but we go a little bit further and we do a bunch of like heuristics to try and figure out what contracts are which. Something pretty unique to StarkNet, although a lot of blockchains have this, is that we have quite a large number of different transaction types, which has been introduced to support things like account abstraction natively, or the fact that instead of you deploying new bytecode every time you have a contract, you just have one instance of it, and you deploy just the instance of the state. So actually the state roots of StarkNet are smaller than the state roots of Ethereum, which is kind of cool. And in this, you'll see that on the top left here, I know the screen is terrible, so just imagine there's a bunch of nice like features to filter between the different contract types or the transaction types to figure out like maybe you're just interested in all the deploy contracts, like the deployments that have been made. There's also some nice things here to support multi-call. Speaking of which, I think Julian was just talking about multi-calls. We decode them all, so you can see what a transaction has been doing, every single subcall that it's been doing. There's some talk, here's fun alpha, in the StarkNet community to make your multi-calls programmable. So if you say that your output number 2 of multi-call, like the first call, can be the input of the subsequent calls, right? So you can chain the data through the multi-calls in like a trusted way. So instead of doing like ENS resolution off-chain and then passing in the address and someone signing like a random thing, they can see in the message that they're signing that they are using the ENS address directly. Then we can resolve it and we can pass it in to say the swap function to be the receiver, for example. And that's really cool because you can pass a lot more data and you can make it a lot clearer to users like what is happening in these calls. And it's also safer, like depending on how you structure it. So that's something that's coming up like in the near future. Keep an eye out for some snips and people like discussing this. Still like very early on. Right, so Voyager also embeds a bunch of like on-ramps and so on. I think the direction we want to go here is like if you're a developer and you want to do something quickly, like you should just have all of it available for you right there. Like we don't want to compete with wallets. We don't want to compete in this direction. We just want to have everything available to a user that they might want in the development process. So yeah, there are more integrations coming along. So you'll be able to like on-ramp with a bunch of different pieces. You'll also be able to do swaps with various different providers, all inside of Voyager, so that you can like manage the state of your contracts. Okay, so this is the part that I'm actually really excited about. It's one of my favorite parts of Voyager. We have stats. Normally, there are a lot of stats in blockchains that are like the usual ones, I'm going to say. How many active accounts have there been? What's the TVL? What kind of transactions are happening? Which contracts have the most users and the highest number of transactions that have occurred? I wanted to focus on the fact that StarkNet is fundamentally different architecture to a lot of things. It's an L2. So like, what does that mean? How long are the proof times? What is the gas cost of L2 in comparison to L1 in real time? Not just like, oh, it's generally like 1/10. Like, I want to see exactly how much it costs and why it changed. So in this one, this is the fee of doing like somewhat equivalent transactions on L1 and L2. The top line is on Ethereum and the bottom green line is on StarkNet. And you can immediately see like the savings are 0.1%. That's the fee compared to the L1. Now caveat, this is on Goerli, this is a testnet. On mainnet it's a slightly different picture and I'll show it to you next. But something that's really interesting to note here is See this spike on the left? And then you'll see the spike again on the StarkNet instance, but just after. So now you know, for example, that the way the StarkNet is computing their fees is actually retroactive. Like they're footing the cost of doing the rollup when the gas fees are high, and then charging more on the next transactions, right? So this is the kind of insights that Voyager will give you on how the economics of the various layers of StarkNet work. And we have a few more of these, and we're broadening them out. Like, what's the latency of doing your proofs? Are the L1 proofs, are the L1 state updates in sync nicely with the L2s, or are you getting like jitter in comparison to them, or like, you know, various different metrics here. Here's an example of like MySwap versus Uniswap v2, and again, like the fees are minuscule in comparison, right? On Goerli once again, and then on okay, so this is mainnet. Now this is interesting. Before, they traced almost perfectly, right? They're like highly correlated. They just offset a little bit. On mainnet, it's not the case. It's 7%. So you might wonder, like, why is this different? And the reason is, like, StarkWare is currently the one sequencer that's working on mainnet, so they're hedging against the costs, and they're charging a little extra to make sure that if the two get super out of sync, they don't end up like hemorrhaging a bunch of money to the users, right? So this mechanic is going to start coming in more and more in like when we decentralize and when we have prover markets. You'll start seeing that the costs will be a little bit more than what the actual cost is to like protect against this, right? And so all of it's kind of going down on Voyager. So if you're interested in how like decentralization affects these numbers, if you're interested in how Cairo 1 is going to affect these numbers, if you think Cairo 1 is going to make people make much bigger programs than there were before, you can see how they're influencing like these basic metrics on Voyager. It's all going down here. Go check it out on Voyager. Long story short, Voyager's cool. Check out Voyager. Move it on. Yeah. Okay. TPS here. This one next 6 months. Keep a very close eye on this particular metric. Cool. We also have a CLI verifier for the devs out there. Use it. You can verify all your contracts. I highly recommend that you give it all a spin and check out Voyager. Okay, next one. We have Juno. Juno is a full node implementation, or a quasi full node. It is intended to be a full node, just like all the others that are out there in this space. So one of the nice things about StarkNet, which actually puts it ahead of a lot of other rollups in my opinion, especially ZK ones, is that we already have the start of client diversity here, right? We're not just going with one client and then hoping that the others will follow. They're building 3 at the same time, and Juno is one of these 3. In the roadmap here, the next step for these clients is they've finally gotten to the point where they're indexing all the blocks. They need to start talking. So we're going to be working on the P2P specification and how they're going to start nattering away at each other in the next few months. And then on top of that is the work that's being done by StarkWare. And this is actually very interesting if you're into the development of the protocol. So they're trying to figure out how to do consensus between the sequencers, how to do permissionless proving, and what types of markets you should design to make sure that the incentives align. Ilya from StarkWare has been making an amazing series of posts which goes into all of the trade-offs and all of the depth here on the community forum. So if you want to know what's going on in StarkNet, check out what's going on in here. There's more and more of a push to make all the conversation be open and be on this forum, and I highly recommend that if you're interested to just ape in on these on these threads and say, I don't agree with this trade-off. Or if you are looking at building products that are going to mitigate some of the trade-offs that will be the result of the decisions made here, this is where you can figure out what to build in 6 months. So read through all of these, they're definitely worth seeing. Also, Ilya is a genius, so it's just nice to read what he writes. It's all very clear. Cool, next one. We have a lot, we've got a lot of things here. So in this instance, we have Warp. Now, Warp is a Solidity to Cairo compiler. It takes in Solidity code, so say your basic mint function. And I mean, if you know what compilers are, blah, 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 fine. But it produces the Cairo code for you. This means that large Solidity projects can migrate we just, like, quite a while ago we announced that we had done Uniswap v3 via this method. And I never actually like revealed what the testnet address is. So if you guys want to check out Uniswap v3 on StarkNet DevNet, like on testnet, like snap this and yeah, just play around with the pools. It's fully functioning, and yeah, currently has no users because it was just me, but now it's you. So please get onto it. Yeah, he's ready to go. I'm really proud of this logo. It's you got the StarkNet logo and the Uniswap like horn thing. I'm not a designer, but I'm proud of this one. So yeah, if you're wondering how to test the stuff that Warp produces, we have like hooked into Hardhat, and it will automatically compile all of your Solidity Cairo. It will spin up its own DevNet. It will deploy it onto the DevNet, and it will test all of your normal test suite against this instance, doing all the translation of the types on the fly, which means that you can be like pretty damn sure that it's working correctly. And now Warp is going through a drive to like add fuzzing and add like a bunch of extra security checks. Like we're working on maturing the security profile of Warp. And the next big thing for Warp is that Cairo 1 requires like a significant like rewrite of certain sections of it. So that's the process that's happening now for Warp. It's updating to the latest version. But it'll make it a lot cleaner, a lot nicer, so I'm quite excited for that. One of the things that you should know here is like you get immutability out of the box, so you don't have to deal with the immutable memory model of Cairo yourself if you're writing in Solidity, which is a nice little property. Cool. This is just a footnote. We work with ENS to do resolution of domain names on L2, right? Not useful if you're doing just yours, unless you're a StarkNet Maxi, in which case just have fun with it. But if you are going to start like issuing a ton of subdomains, it's way cheaper if you go through StarkNet. And we have like really good support for this. So if anyone wants to start issuing lots and lots of subdomains on ENS, and you don't want to pay all the gas for it, like come talk to us and we can hook you up with the system basically. I know that like, I don't know if it's alpha, but Argent's looking at it and a few others. Also, can people hear me properly, or is it a bit, yeah, okay, cool. Yeah, this is actually on testnet working. This is just the normal ENS page, but you'll see that this address here, this final volume that's been like resolved, actually came from StarkNet using CCIP read. If you're interested in CCIP read and its construction, come talk to me. I've been looking at it like endlessly for the last week. Cool. The last one, I'm going to make this very short, and it's actually one of our most exciting tools at the moment, is Horus. And Horus is a formal verification tool for Cairo. It allows you, in your code, to specify what your invariants are and what your constraints are of the implementation. And then it will just throw it at a massive SMT checker and like basically tell you whether or not those invariants hold. So if you want to write super secure code, you can actually use Horus like throughout the development lifecycle. Like you can start writing code and immediately instrument it with Horus and see that your code is like matching the expectations that you're making. And at the same time, you're kind of building a formal model of what your code should be. So if later you want to do interactive theorem proving, you can just pull out the assumptions you made from Horus, right? So like this is an incredible piece of software, and it's really rare that like a rollup or an L1 comes with this before it's like even reached like full maturity, right? Like so this is an amazing tool to have from the start, and I would love to see projects picking this up as part of their like basic instrumentation on the first step of their implementation, rather than like trying to figure out security and formal verification at the end and like shoehorning it in. If you're interested in this, Julian is giving a workshop. Julian is the guy who wrote this. He's a genius. He knows everything about formal verification. I hope you heard me say that because he's going to like bollock me for later. He's in the workshop room back there. He will teach you how to install it. He'll teach you how to use it. He'll teach you how to think about it. And generally, he's just a very interesting guy to talk to. So please go to that talk. Horus workshop in the workshop room off the side here. And that is it. That is, yeah, don't get wrecked. Yeah, cool. As always, Nethermind is hiring. We do a bunch of really cool projects. We try to do hard things, so come and talk to us if you're interested. And we also like to help protocols grow, so that's why we're here. That's it, guys. Thank you very much for your time. and see you at the next event. Yay, thank you. All right. Cheers.